Hello, everyone. Thank you for joining us today as we come together to learn more about building and deploying JavaScript web APIs to the cloud. My name is Hussam Mohsine. I'm the program manager for Microsoft Reactor Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Chris Nwamba. Chris is a senior developer advocate at Microsoft. He's a JavaScript developer, community champion, author, and speaker. He spends most of his time helping all levels of developers in Africa move from beginner to their career ambitions. Chris helps co-organize the largest conference and developer community in Africa, Concatenate Conference, and ForLoop Africa, respectively. Feel free to ask questions during the session. We will have regular stops to answer these questions. And also feel free to tweet about the session and tag us on Reactor Abu Dhabi. That's the hashtag on Twitter. And also the Twitter handle is MSFT Reactor. That's for the global reactors. And also make sure you adjust the playback settings to select the highest quality, since we will be coding in today's session. With all that said, I hand over the mic to our speaker to start the session.
Hi, everyone. Thank you for making all the time to join me today. Thank you, Hussam, for the introduction. You are amazing. Yeah, so I promise everyone on this session that at the end of today, you are going to be able to do 4 things. 1, you're going to be able to build a CRUD app, a CRUD API with Node, and then you're going to be able to deploy that CRUD API to the cloud. And while deploying to the cloud, we'll set up continuous deployment so that we don't have to always push deploy for every commit we make. So when we set up continuous deployment with GitHub, we basically get automatic deploys for every changes we're going to make. And then lastly, you also see how to set up integration testing for our project and run those tests for every commit and make sure that you don't deploy failing tests to production. Just like Hussam said, my name is Christian Nwamba, and I'm a senior cloud advocate at Microsoft, focusing on Azure, JavaScript, and startups. Now, I hope you don't mind. I'm going to share my screen right now so you can see all the resources you need for this workshop and start following along. Hussam, can I share my screen now?
Yes, please go ahead.
Okay, cool. Yeah. Hussam, can you see my screen? I think it's just you that can use to confirm what's going on. So I'm guessing you can see my screen right now, right, Hussam?
Yes, it's live.
Okay, perfect. Yeah. Now this is the GitHub repository that contains all the resources and all the content for this workshop. And as you can see, it's divided into exercises. So there's exercise 1, exercise 2, 3, 4, 5, and then 6, 7, and 8. So it's a 2 hours packed of hands-on exercises, and you're going to learn a lot of things from this workshop. But before we actually get started, feel free to go to this link. It's bit.ly/crud-api-node. Now this URL will bring you to this exact repository. If you're not on your computer, take a screenshot of it, because at the end of the day, you could just follow the steps in the exercise to get along. We're going to paste this in the Q&A section. So if you don't have access to getting this right now, you can always copy it from the Q&A for this workshop. Cool. So let's all have it. Just like I promised, at the end of the day, you're going to end up going home with this 4 skills: being able to set up a RESTful API, configure CI/CD for your API, run integrated tests on the CI/CD pipeline, and then deploy to your API. But why exactly did I do this? Did I make this workshop? It's not like if you go out there, you won't find resources that would help you achieve each of these points. Why I made this workshop is because mostly when we see contents out there, these contents are basically telling you how to do like the beginner stuff, how to create a Node API, but it doesn't necessarily show you how to actually set up routing for a RESTful API endpoint. But then the next day, the article you encounter is already like telling you about advanced stuff you can do with Node and advanced cloud computing stuff you can do. It's basically like when people make this a fun of this old drawing where today you see how to draw circles, tomorrow you see a complete drawing of an old. How about the gaps between drawing circles and making a complete old? So today I'm going to try my best to fill up those gaps and gradually draw this old from just circles to a complete animal. Yeah, so how can you participate in this workshop? Any way you choose to join this workshop is fine, but I would really appreciate if you can follow along. If you're using VS Code, the repository we're going to clone contains snippets, so you don't have to actually type every single code I'm writing. You can basically like use shortcuts, and you see the shortcuts in each of the tasks. So for example, if I want to let's take this example, this code snippet, for example, it has this particular snippet. So if you copy this and paste in VS Code and hit tab, it will generate this particular code for you. So you don't have to literally type every single line we have here. Then secondly, it's okay if you just want to sit on your couch in your sitting room and just follow the workshop. You don't have to do everything from scratch alongside with me. But I'm going to ask you to do me a favor. At the end of the workshop, when you have the time, go back and watch the video for this workshop or take this repository. It's a step-by-step guide and repeat everything I'm going to do today. So you can actually practice how to do this and then get very used to it. And then thirdly, if you join late or for some reason you are not able to follow along as quickly as I'm moving, you can always copy a particular, like you can check out a particular commit. So if you go to the commits for this repository, you can see that each of the exercises has their commit names. So you can basically check out a particular one. I think this is a typo. This should be exercise 7. But yeah, you can check out a particular commit. If you open if you type git checkout, you would basically paste this hash for the commit, and then you can check out that commit immediately. So you don't have to actually type from scratch if you missed anything. Cool. The prerequisite would be to have a free Azure account. If you don't have a free Azure account, you would need to create one while I'm just speaking, because you're going to need your account to be able to deploy your app to the cloud. And then of course you need Node.js installed, and VS Code is optional, but if you want to use the snippet stuff I spoke about earlier, you would need VS Code because the snippets are actually stored in the .vs code folder. So if you open the .vs code, you will see all the snippets right in that folder. Then of course you would need some level of JS fundamentals and some level of Node.js basics to be able to understand what's going on in the code. Cool. Hussam, I'm going to pause for a while and see if I lost anyone while doing introduction before we head to exercise 1. Are there any questions in the QA?
It's fine. There are no questions yet.
Okay, cool. Yeah. So I'm going to move on then. So we're going to start with the first exercise, and the first exercise is just to set up the repository and test it and see if we have everything we need to start working. If you're joining late, I know Hussam must have pasted the repository in the QA, but basically just go to bit.ly/crud-api-node. So we're going to start with the first exercise and the first task, which is basically to clone this repository. And to do that, I'm going to copy this, move to my terminal, paste this in my terminal, and then hit enter. Now, what this is going to do is that it's going to clone the starter repository. This is not the same repository we're looking at right now. It's a different repository that has just the starter code. This one has the completed project. Now, cd into this repository. And then we can open VS Code here. Just going to make this full screen. Cool. We just completed the first task for exercise 1. The second task is to walk through the code. I'm going to first of all explain to you what the project tree for this code looks like. And if you take a look at the root of the project, you would see this test the data.json and test data.json. Now these files are basically there to help us seed our database. So if I run a command, a script I defined in package.json, which is a seed script, basically running npm run seed, I would basically populate my database with all this content here. It's just there for us to have like test data to play with. You don't have to worry so much about this. And the second thing I need you to pay close attention is the package.json file. Here are the scripts we need to pay attention to. The start script is there. We're not going to use the start script, but the server is going to use it to start the app every time we deploy. So Azure automatically runs npm start every single time we make a deploy. And then the dev command is what we're actually going to use for testing locally. We're going to use node-mond, which would allow us to watch file changes that are related to the index.js files. Then remember the seed command I told you about. Basically, what it does is that it takes a look at this utils.seed.js file and runs the actual function that it exports. Flush is the opposite of seed. It basically empties the database. Then test dev runs the test using the watch flag. So if we run a test, we can just leave it running while we make changes to our file, and the test keeps running. While the test command just runs and exits immediately. That's why we have the exit flag. Then heading back to the index file, which is started by the start or the dev script. What's going on is, first of all, we're importing Express and body parser. Express is basically a HTTP/API/routing framework for Node. So if you wanted to handle HTTP requests, instead of going the manual way of importing the HTTP module for Node, you could use Express to basically make your life easy. Then the body parser library is responsible for extracting the payload from a post request and then passing it to a request of body. So if you sent a request to an endpoint, say this gets, or let's say this is a post endpoint, if you sent a request to it, the only way you could extract the body of that request is by making sure that you have a body parser installed and configure it to be able to pass JSON and URL encoded contents. And this is what an express route looks like. Basically, you call either one of the HTTP, you call it any of the HTTP methods. You can either do a .get or a .post or a .put request, pass the URL that the user is supposed to visit or call or run or whatever. And then the second argument is the handler. So the second argument is a function that is executed when this URL is visited. So basically, we are going to send a response that says welcome to our API. So this you can take this as the home page of our API. Then lastly, or second to the last, we are listening to the server starts listening to this particular port we have set up here. Now, if we're checking if process.env.port exists, and if it doesn't, we would use port 4000. I'm just going to close all this. It would use port 4000. Now, why we're doing this is because Azure is going to set this port for us automatically and use this port and then use this port for when starting the app. But locally, we're not going to do this. We're just going to use for the port 4000 to manually start the app. Then, if you're wondering why I'm doing this, I have this check which checks for the parent of which checks which runs a module of parent check. What basically happens is I want to make sure that this file is only started when I run Node directly on it, and not maybe when a file or another process tries to start it. This is helpful because when you are running tests, every single time you run a test and the test is in watch mode, it tries to re-listen to this port, and unfortunately the port would already exist by then, so it keeps on throwing an error. So this is just an error checking mechanism. It can totally ignore it if you don't want to use it. Lastly, we just have these test files. In the home.js, you would see a simple test file that just checks if you send a request to the get endpoint, what would you get back? So you should get back a 400 status response. You should get back a text, and then you should also get a text that says welcome to our API. Then the database test checks if the connection is successful. Mind you, we haven't written any database logic, so if I run this test, it's going to fail, and that's why I have these skip flags to both DB and the articles test. The article test for all our API endpoints, but these two tests are going to be skipped when we run npm run test, and that's basically what I'm using this regex or this glob pattern to ignore. Now, the next thing we'll do is to basically go back to this CLI and run npm install to install all the dependencies that are in package.json. So you can see I have body parser, express, MongoDB, chalk, and .env. .env is just for us to be able to pass our environmental variables, and then chalk is just to like have fancy log into the console. Then the dev dependencies are all testing tools as well as NodeMon. And once this is done running, you can run npm run test, and you can see the only test that we ran was just the home test. We skipped both the DB and the articles test because these tests right now are going to fail because we don't have any logic for the database and we don't have any logic for the articles. This is actually the end of exercise 1. Does anyone have a question so far? So Sam, are there any questions in the Q&A? Let me see. Cool.
So there was one, just a quick one,
okay.
Chris. Under the Q&A tab, just one of the participants mentioned a issue with the repository when they tried to clone. So if you can navigate to that Q&A tab under new.
Yeah, I can see it now. Let me quickly fix it. This is entirely my fault. If the repository is private, I was supposed to make it public before the workshop started. So I'm going to quickly set this to public. And okay, so if you try cloning once more, this should be fine now. It's public now. This is entirely my fault. I was supposed to do this before the workshop. Okay. So since we don't have any more questions, I'm going to move on to the second exercise, which is basically setting up our cloud resources. Now, we have just 2 hours for this workshop, and I was really hoping to make it 1 hour 30 minutes so I don't keep you waiting for so long. And that's why I went ahead to create all these resources for myself, because it takes a little bit of time to create them. But I'm going to walk you through each of them just in case you want to watch the video later or pause it. But feel free to if you have a very good internet, feel free to run these commands and set up the resources in the cloud. And the first one is to install the Azure CLI. The Azure CLI is basically a CLI tool that allows you to literally do anything on Azure. You can create databases, create web app platforms, like spin up containers, spin up virtual machines, rather, and like destroy stuff if you want. So you just need to install this on your computer, and you can do that either for Windows or for Mac or for Linux. I'm using Mac, so I had to just use Brew. First of all, update Brew and run Brew, install Azure Cli to install this. Now, if you don't want to use this, you can also go to shell. Make sure you're logged in. Go to shell.azure.com. Now, what this will take you to a cloud shell. So you don't have to actually like install the CLI tool. You can do this in the cloud. You can like do this in your browser and set up all the tools without having to use a CLI tool. And if you're also having issues using the CLI tool, whether locally or in the cloud, just like I pointed out here, what you can do is scroll to the bottom of the page. You can see an appendix page where you can use the user interface for Azure to create these resources manually. Now, once you have this installed, I already have this installed, so I'm not going to run it again. Once you have this installed, run AZ login. This, remember, I told you you're going to need an Azure account for this. So run AZ login. Azure would try to log in. It would take you to a browser to authenticate and then redirect you back to your CLI. And from then henceforth, you can start running Azure AZ commands. But remember, if you're using the Azure Cloud, you're already logged in. The Azure Cloud shell, you're already logged in, so you don't have to run AZ login here. But if you are doing this directly from your CLI, you have to basically come here and type AZ login. And the third step is to set your default subscription. There's a chance you probably have more than one subscription in your account. Every single time you try to create a resource, you'll be asked to provide a subscription. So instead of always getting that annoying prompt to add a subscription or the annoying error, basically run account list. AZ account list is to print all your subscriptions and take the ID, copy the ID. This is the ID. That's the second thing that you would see in your subscription. Take the ID of the default or the subscription you want to use most of the time, and then run this command on it. The command would be AZ account set subscription to then the subscription ID here. Now what this does is subsequently, whenever you try to do anything with your resources, it's not going to ask you for the subscription ID anymore. Then the fourth step is to now create the resources. We are done with logging in and like setting up a cloud account. The next thing is actually start creating these resources. Now we need to create four things. The first one is the resource group. A resource group is basically an entity that helps you organize your resources. So it's just an administrative grouping that you could use to imagine it as a folder that holds other resources like databases and web apps. So you can have a project, name that project, give your resource group the name of your project, then put all the resources related to that project inside a folder. And second thing we need to create is a MongoDB database. We're going to use Cosmos DB for this, but we actually need to create two databases, a test one and a production one. This way we don't have to mess with our production data every single time we run tests. And we need to also create a service plan. A service plan is basically something we use in creating APIs that allows, this is where you manage things like pricing and the operating system you want to use for the platform that's going to host your API. So we'd see that by the time you get to creating the web API, you would need that service plan. It manages your pricing as well as the operating system that the web app is going to use. And let's start with the resource group. First of all, copy this code. Feel free to change the name to whatever you want, but copy this block of command tool and paste it in your CLI. assuming you're already logged in. So what this would do is it will basically create a resource group named CRUD API node. Feel free to change this. It doesn't need to be globally unique, but so you can name just CRUD API node as well. But it's okay for you to change it as long as there are no white spaces or some characters in them. Then secondly, copy this to create the test database. Now you can see I named mine CRUD API node DB test, and the resource group is CRUD API node. So this has to match whatever you used when you were creating the resource. And of course, we're setting the kind to MongoDB. Now, why we're doing this is because Cosmos DB supports different types of protocols or different types of databases. You can use MongoDB, use SQL, Cassandra, Elasticsearch, whatever works for you, whatever document database works for you. But since in the Node ecosystem, we're much more comfortable with MongoDB, that's why I'm using it for this example. Now I have to warn you though, the name for this Cosmos DB has to be uniquely, globally unique. And what that means is that if this is the name of my own database, no other person that is an Azure customer can use this. So make sure you probably do something like this, add a number at the end of your own Cosmos DB name. Maybe try your date of birth. Then we need to get the primary key for this database. The primary key is what we're going to use to form the connection string. It's basically like it's not the entire connection string, but towards the end, towards the middle of this workshop, you will get to see how you can use this primary key to create a connection string that can then use in your application. Now, this second stage is basically the same thing we did in this one, but I removed the test name just to. It's basically the same type, the same process. But I'm trying to create another database for production. The previous one we did was for test. And moving forward, run this command to create the service plan. Remember, I told you the service plan helps you manage things like pricing and helps you. And then this is the point where you can choose the operating system you want to use for your web API platforms. So we want to use Linux, and then this is like the code name for particular pricing category on Azure. It's very, very cheap, so don't worry about using. If you want to use this exact one, it's fine. And of course, make sure it matches the same resource group we created earlier, and then give it a unique name. And then lastly, we then create our the web app for our API. At this point, if you run this, is just going to be an empty container for deploying web apps. Now, give it a name. I give it the same name as my resource group because this is the primary resource in this project. But remember that this is going to be this has to be globally unique. So if you try to use the same name, you're going to get an error. So maybe add some numbers at the end to make yours stand out. Then remember the plan we created earlier, that's what we're using for this web app. And then lastly, we are also setting the resource group to CRUD API node. Now you can also set the runtime. This is basically which programming language are you using and which version of that programming language you want to use. I'm using something that is fairly new, which is 12.9. I'm just going to give everyone about 3-5 minutes to set all this up because it's a lot and it would take some time for you to run them. And if you have questions, feel free to send them in a Q&A. I would attend to them while I'm waiting for everybody to get set up. Now, if you head back to the editor, you would see that I have this .env.example file and .test.env.example file. I'm going to rename this. I'm going to basically rename both of them and remove the example suffix. Now, notice once I do this, it grays out the .env because it's git ignored, and which means that if I push this project to GitHub, this is not going to go with it. Going to do the same thing, and also now these two files are going to represent our different environmental. This is going to be where we set different environmental variables for different scenarios. So if I'm running tests, I want to make sure that that I'm getting all the credentials from this file, and if I'm running like production stuff, I want to make sure I'm getting all the credentials from this file. Once you have that set up, copy these two credentials and paste them here. Paste them in both .env and .test. Now replace name with whatever is the name of your Cosmos DB. So mine is CRUD API node. Same thing here. CRUD -API -node. I'm going to check if I have any other placeholder. No, I don't have any other one. And the primary key is the same primary key that would generate when you run this command, when you did the key list command, when you did the AZ command key, AZ Cosmos DB key list. The primary key that was generated, which you probably copied and saved somewhere, replace it with this placeholder. Now I'm going to copy mine. I already like have all this generated, so I don't have to run this command, but I'm just going to copy one. And paste it here. I'm just going to use the same database connection string for both tests and production, but the point is that you get the gist. You don't have to use different databases if you don't want. But in real life, you would want to keep those things, keep the test data and the production data different. You don't want to mix them because things would like really definitely get weird if you're not careful. And the last one of the last place we want to set this connection string is in the web app we created. Remember when we ran this command, we created a web app, and this app needs to also be aware of this environmental variable because when we push this API to Azure, since we're not pushing the .env file, it doesn't know where to get that credential from. Now the way you can set this is by running this config app settings set command. What that would do is to take whatever you provide in the settings argument and push it to your container. So run this command, remember to replace all the placeholders, replace name, primary key, and name as well before pushing. And while replacing, please don't include while replacing, remove the HTML like or the greater than and less than signs. Remove these two signs. You can see how I did mine here. So make sure you remove those while you are replacing. I'm going to pause for a while because moving forward, we're going to start seeing a lot of code. So we're just going to make sure that everyone is following along. If you try to create, I have two questions in the Q&A. If you try to create an Azure account, you wouldn't need, you might need to supply your credit card, but you wouldn't need to pay for anything to do this. You have about $200 credits to use. You don't have to pay for this. By the way, I'm just taking the questions from the Q&A. So while remember the link is bit.ly/crud-api-node. So while I'm taking the questions in the Q&A, feel free to run all the commands you have here and try to catch up. It's okay if you're unable to like immediately follow along. The session is recorded, and we're going to provide the link at the end of the workshop. And the good thing is, I really spent a lot of time in creating this content. So even if you don't get the video, just go through the contents on the GitHub page, and you should be fine. You won't need the video to actually like run all these commands and do everything from beginning to the end.
Yes, Chris. So the session is recorded and will be still available on the same link. We will also try to get it on our YouTube page very soon. So for everyone watching, follow along on the GitHub repo, which is already posted in the Q&A as an announcement. And also keep the session link. You will be able to access it also after the session ends.
Thank you, Hussam. Okay, let's write some code. If you head back to the code editor, we want to start creating the GitHub. We actually want to like push this code right now to the cloud, and to do that, I'm going to need to create the action file or the action workflow file to define what the steps for deploying this to the cloud, the steps that GitHub needs to take to deploy this to the cloud. And if you're wondering why I'm not doing this at the end of the project, why I'm doing it so early, it's because I'm trying to make sure you understand the culture of building, like setting DevOps at the beginning of your project and not doing it at the end, because that way you build a better habit of always having CI/CD set up properly, and like you have to deal with those things as early as possible in your project lifecycle, and not like leave it as an afterthought, because no matter how amazing your project is, if you don't find a way to put it out there, it's still not useful to anyone. So that's why, in as much as I'm supposed to start teaching how to write CRUD apps in Node, what I'm doing first is to show you how to actually deploy this with GitHub Actions, so you can like learn how to do this as well and get into the habit of doing this, setting this up as early as possible. Now, a GitHub action lives inside a .github/workflows folder. So let's create this folder. So to create this, basically create a folder called .github. And misspell this. It should be .github. And then inside the GitHub folder, add another folder called workflows. And then inside the workflows folder, create a file, deploy.yml. And this YAML file is what we're going to define our actions. And the first thing you want to do in a GitHub action is to define the action, or rather to define the events that should trigger this action to run. And just like when you have an on-click event, or when you have like on-click event in browser, when you like create custom events. And the event that we want to trigger a build is a push event. So to define an event, we use the on property, and we're also giving this action a name. We are just calling it deploy CRUD API to Azure. Remember, if you want to also run these actions when a pull request happens, you can basically add that in this array. But right now, I'm just sticking with only pushing. Now, what we've done is to create an event. But what happens when this event is triggered? What's the handler? Now, the way actions, what action calls handlers are jobs. Now, if I create a job, you basically create a jobs property. Now, another property, define give the jobs a name. We're going to call these jobs build and deploy. It can be anything you want. And then we need to tell GitHub which operating system we need it to set up for running this action. We are going to just use Ubuntu, and then we can go ahead and start defining the steps to the steps for this action. Right now, an empty operating system is useless to us because we have not actually said, okay, clone the repository, run npm install and test, then deploy to Azure. We haven't said any of that. We're just saying, hey, create an operating system. Now, to create a step, you basically steps are just, you can just create a step as list or array or whatever you want to call them. But the first thing you want to do is to, do you remember when I told you about the snippets? This is how you activate them. So if you run _, you would see all the possible snippets. Then you can just choose the ones that you need to use. Now, the first thing we want to do is to check out the repository. Checking out basically is think about it as cloning this repository into the mini computer or mini container that GitHub is going to set up for running this action. And the next step, let me first of all check if there are questions in the QA before I keep going. Okay. The next step is to log into Azure. Since we need to actually push this, basically build this repository and push it to Azure, we need to be able to log into Azure from GitHub Actions. So let's define an action step that actually does the Azure login. On this, what this does is, whenever you see a uses property, it can basically either define a script here or use another action, or maybe like passing just a Docker container that can handle this step. But for the cloning, we're using this checkout action. For logging into Azure, we're using this Azure/login action. But then we need to pass it a credential, and that credential is the Azure we're going to call it Azure credentials. You can call it anything as long as when you're setting up this secret, which we're going to see very soon, make sure you name it the same thing. So we're going to pass it a secret, and this secret is like, think about it as your Azure username and password. This is the only way GitHub can be able to authenticate on your behalf. The next step is to actually set up Node. Since we are going to use Node to do to run our tests and build the project and be sure everything looks good, we need to set up Node, and before we can then define a step to run npm install, then run the build and run our tests. And the most important part of these steps is to deploy this app to Azure. Now, the deploy to Azure command uses an Azure/web apps deploy actions, and the only thing it takes is the name of the web app we want to deploy. Remember when we created the web app resource, we named it CRUD API node. So make sure whatever you named your web app or web API is what you're going to pass in here, because if you don't do that, you would end up deploying into the wrong resource. And lastly, we want to log out of Azure. And trust me, this is all you need to do to set up continuous deployment. You are literally done with CI/CD. There's nothing else. There's not a magic to do. The only thing we need to do now is to set this Azure credentials secret. And to do that, if we head back to the exercises and open the Get Azure Credentials part, and once you copy this code and run it in your CLI, remember to pass in the subscription ID that for the particular that you set as default at the beginning, then passing the resource group. In this case, it would be crud-api-node, and then here passing the name of the website, which is also crud-api-node, which like these are just the resources we created earlier. Now, once you run this command, it would basically generate a JSON payload that contains the client ID and the client secrets that you can use to authenticate this app. Now, if you once you have this, if you head to Azure, to GitHub rather, and create a new repository. I'm going to call this CRUD-API-node demo. I'm going to make this public, then create a repository. Now, this is an empty repository, but what we want to do is this is where we're going to end up pushing our code, our API to. But right now, what we want to do is to set up the secrets for the action that this particular Azure credential secret that the action needs. If you go to settings and click on secrets and click on add new secret, we can basically copy the same name, paste it here, then copy whatever Azure credentials you got from Azure and paste it here. Now I have my Azure credentials set up. If I push this code to GitHub, let me just commit all this. I'm going to say initial commit. if I head back to the terminal and run git push, I'm going to change this to demo, which is the repository we created, and then hit enter. And if I head back to the browser, go to the repository, you can see that we have our code pushed here and our .env files are ignored, so our secrets are not exposed here. Now, if you go to the repository, to the .github/workflows file and open the deploy.yml file, you will still see our action. It's fine, it's all here, but where things start getting amazing is when you go to the actions tab. And you can see that the initial commit actually is being deployed. If I open this commit and click on the job we defined, remember this points to this. This points to this. So if I open that job, you can see that we're already able to set up a job, check out, clone the repository. We're able to log into Azure because our credentials were correct. We're able to set up Node. You can see our tests are passing, and then it's now deploying to Azure. So there is a 99% chance this deploy should work because everything looks good on this other side. Yeah, you can see this says the deploy was successful, and then it actually gave you the deploy URL. So if I copy this URL and then basically run call the URL, hit enter, I should get welcome to our API message, which is exactly the same thing you would do if you went to the browser to do this. All right. I'm still getting the same message which says welcome to our API. So you can see we just legit used GitHub Actions to set up CI/CD as early as possible. It wasn't so difficult to do this, and now henceforth every single thing we do, every single code we write, we can run tests on this code, push them to GitHub. GitHub automatically push those changes for us to our web app platform. I'm going to take some questions if you have any before I move on to actually building out the crude API. I'm just taking a look at the questions tab. Where can I find location for codes? Yeah, so just going to show this one more time. If you weren't able to come early enough, just go to bit.ly-crud-api-node. If you click on this link or if you open this link in your browser, every single thing you need for this workshop is here. Both the completed code, the starter code, and all the instructions on how to set this up, right? Follow the workshop from beginning to the end. Cool. Since I'm not getting any new questions, I will just move on. And the next stage is to actually start building out our RESTful API. But before we do that, I would like us to take a look at what routing looks like with Express. So Express is the thing we installed super early at the beginning of this workshop, which is this Node module. It's like one of the most powerful libraries for Node out there. And fundamentally, you can do routing with just using with whatever, like the object that Express returns. You can use it to make, like, set up routes, but this is not very efficient. It's just there for you to do basic routing stuff. If you really want to if you really want to go neck deep into building RESTful APIs, you're going to need to use the Express router. And set up the router, you would basically call express.router function, which returns a router object. So this should be E4. Then you can use this router object to create routes. Now, once you've created this route, you can before listening to the port, you can mount this port on the app object. What we can do is now, once we do this, this endpoint is going to end up being very different from this. And why this is the case is because we're asking this router to be whatever is defined by this router object should only be mounted at the /API path, not necessarily the homepage path. If I save this, go to the terminal and run call http localhost 4000/API. Yeah, and I have to start the app first, so I can do npm run dev. Now, once the app is running, we can open a new window and then use call on this endpoint once more. Now you can see I'm getting a different message which says, "Hooray, welcome to our API." And you can see this is actually a JSON. Unlike this is just sending a plain text. This is sending a JSON, and there are two different things. If I actually tested just the 4000 API, it would return the first route, and this could serve as the website's homepage, and then the router.get version will serve as API homepage. And where the router object starts getting really interesting is I can do stuff like this. Let's say I can, instead of just calling post or .get directly, I can call the route and pass it a path. Now I can just register both post and get requests on this route. So what this basically means is that if I send a post request to ping, I would get this response. But if I send a get request to ping, I'll get this response. We can test this out as well by also using call /API/ping. Let me make sure I save this. Yeah, the ping, not ping. You can see you get a ping message, which is what happens when you run a get request. And if you try a post request, you can do a post request with call by just passing it the data flag. You would get a post response. And before we get too excited and start like building like all these fancy routes, let's go set up our database. Now, to create, we already have a database set up, so we're not necessarily going to set up a database, but we're going to set up our database SDK client to be able to connect to the database we have already deployed, already have set up in Azure. And to do that, I don't want to put the logic for the database in this file. So what I'm going to do is create a new folder. It's going to collapse all this. Create a new folder called DB. And inside that folder, add a simple, just an index.js file. Now, the first thing we want to do inside this file is to import the MongoDB clients that we're going to use for our actually creating this connection. So we can do it here. Now, not just the client, we're also importing the config file. Yeah, the config module, and the config module basically contains all of our configuration files. So everything that it handles passing the env files using .env. So it's as simple as just calling .env.config. And what this would do is attach all of our environmental variables on process.env. So that way we can then set this to an object and just return it. Now, this way we can then use this file to create a client. Now, a client does nothing. A client is just an instance of the MongoDB SDK. It usually does nothing. It just takes a URL and creates a client interface. What we can do with this client then is to create a connection. And this connection takes in the URL. It gets the URL from the config and then passes it to the create database client, which is what we define here. And it returns the client. And then call the client.connect method. This is the actual thing that happens here. It connects to the database, you call this client.connect method, and then you can return the connection. Now, what we can do with this is for every single file that needs to talk to a database, we just call the client connection function, and then like start reusing this function in every other places in our project. Finally, we can export this connection because we can't use it in other files if we don't export it. And to actually make sure that everything is working, I would need to remove the skip flag in the db.js, the db test file. I'm going to rename this and remove the skip flag. And once I do this and run npm run test, you can see it starts testing the database, and the connection was successful. And then it also goes ahead to test our homepage. But this is the important part of this test for us. We just want to make sure that the code we've written to set up this connection works great. And if you take a look at the test, what it's doing is basically calling that same function we created in the database file and just connecting to it. So once it connects to it, it checks if it contains a connected state string. And if that's the case, then the database is then we're connected to the database. Now, what I could have done is just head to creating more route logic for probably our, like, let's say we create REST APIs for an article endpoint or a blog endpoint or a to-do endpoint or whatever you're building, a product or category endpoint. What I could have just done is just to go straight in index.js and start creating this route like we did for ping. But this, for the long run, this would get bloated and not very maintainable. So what I could do is to create a folder at the root of our project, name this folder API. This is going to contain all the API code we're going to write. Then inside this API folder, I'm just going to add another folder that contains all the CRUD logic for each entity. So let's say we have an articles entity. Inside the articles folder can then start adding stuff like create, read, update, delete logic in here. But right now I want to add a model.js file. And what this file is going to do is basically export functions that handle the common stuff that we need from our database, like inserting, updating, reading and deleting. So in that case, we need to import the connection we created. We also need to import the configuration. And then I'm importing this object.id function from MongoDB. What this does basically is convert a string among an ID that's in a string into what MongoDB understands. It's an object ID. And the next thing we can do is to create the insert document method for this. What this does is basically it takes a payload object, creates a connection using this method, create a database using the client that this method returns. Now we're passing the database name to it, and this database name is basically what we have in our environmental variables. And then lastly, we are returning the output of this query. So once it's done, inserting a payload into the articles table, you should return the response of that, or return the result of that of this operation. Now, same thing goes for fetching all documents, but in this case, it's a little bit more straightforward because we are not passing any payload, but it's doing the same thing that the insert document function is doing. And then the only thing that differs is that instead of inserting, it's just finding all the document. This empty object means find everything in this table and return it as an array. The third thing we will need to do in this file is to create an update logic function. This is like insert, but instead of just taking the payload, it takes an ID as a string. Then it converts that ID to an object ID and uses that ID to query the database before replacing whatever it finds with the payload we pass to it. And the last one is the delete document method, and what this does is just like the update ID, but doesn't take a payload. It just basically uses the ID to query for a particular row in the table and just removes that row. Now, all these are useless if we don't export them for another file to be able to use them. So we can just export all of the functions, and we can then start using them in all of our API logic. So let's actually start creating this API logic. Before I move on, I want to make sure there are no questions. Okay, I'm just going to take a minute and reply some QAs, like some private QAs, but feel free to take a look at. If you are lost, you can also go back to the repository, and each of these, like we just covered exercise 5 and exercise 6. Someone is asking how to find all the code names for locations. To do that, run az list az list locations. Let me be sure I have. Yeah, az account list locations, az space account space list locations, and you should be able to get all your locations, like all the possible locations you can use in your terminal. And when we say location, we're referring to like what are the regions where you can deploy your Cosmos or web app to. So exercise 7. Now we are going to actually build the CRUD of CRUD in this application. So since we already created an API folder which contains the articles and the model.js file, just head to the articles file and start adding like each of the files that would represent the CRUD operation. So let's say we'll have create.js. We'll also have read.js. We'll also have update.js. And we should also have delete.js. We need to close all this just to make some room for more files. And for the create route, first of all, we need to export, or rather we need to import the model first, because we're going to use the model to actually run the insert operation. And also I'm importing this HTTP error utility function. What it just basically does, it takes a response, takes an error, and then sends a 500 server error with a message that something broke. So we don't have to, just like a simple error management. It's not the best, but we can just deal with errors with that for now. And then we need to export a function that takes in route. Now, this route object that is received here is exactly the same route object that we use for ping here. So basically, we need to find a way to pass this kind of route down to this create method. So you can basically do something like route.post as well. And as a matter of fact, that's what we're going to do. We're going to do we're basically going to return a route.post function, and then that function is going to take a handler, which is like just same thing we're doing with ping here as well. But this time the function is an asynchronous function because we need to run some asynchronous code that goes to the database to actually insert a document. Now let's actually see the logic that does that. So what we're doing here is we have a try catch block that basically tries to insert into the document, and if it was successful, it would return a response with how many IDs or with the particular ID that was added. But if it failed, it would return an error, if I found an error saying that something broke. Somebody is asking if we always need to call create connection every single time we need to have access to the database. Now remember, every route HTTP is stateless, so every single request you make is just going to be one tunnel that gets destroyed at the end of the day. So you are not going to have access to the instance of the create connection you created in the past once that HTTP request response cycle is terminated. So for every route, you have to basically create a connect, like repeat the same process of creating a connection and doing all that stuff. And for the read part of the code, it's almost the same thing we did with create. Our imports, then we have like we export a function, and the function returns a route.get this time, not a post. But since we don't have any, it's a get request. There's no need for a payload, so nothing is passed to fetch all documents, and the request object is useless, so we just replace it with an underscore. And of course, if anything goes wrong, we also return our error. The update method is pretty much alike like other ones. The same signature, it's just that it calls the update document method and then returns a modified count property. And then lastly, if you're wondering how I'm typing very fast, remember in the beginning of the workshop, I told you about the snippets. So if you just type _, stands for exercise 7, stands for exercise 7, task 5. So from the workshop, from the GitHub repository, you can literally like find each of the snippets right above the file. So you can just run this and you generate the code I'm running. The delete logic is the same thing like others, just that it calls delete documents, takes the parameter of the document it needs to delete, deletes it, and if it fails, we'll get our error handled properly. Now, at this point, we've just created files, like we've just written code that does nothing. Like our entry point does not know anything about what we've done. So we need to find a way to export all of this logic to the index.js file, the entry index.js file. But instead of exporting everything, like crowding everything in the index.js file on the like the entry index.js file we'll have here, what we can do is to create another index.js file in the articles folder. And what this file is going to do is to assemble all of our everything in articles and then export it as one. So first of all, let's import everything we have here, everything we have in this folder, which is the create, read, update, and remove and delete logic. Why I'm naming this remove is because the delete keyword is actually not, you cannot use in JavaScript because it's used to delete keys from objects. So then we need to export a register route function. This function is what we're now going to call in the index.js root entry point. Then lastly, we need to set up two routes. The reason why we're doing this is because we actually have two kinds of routes that we need for our RESTful articles endpoint. The first one is the base route, which handles just the get and the post request. But the second one is the param route, which has to handle a route that receives a parameter. Things like update and delete needs a parameter for us to be able to update and delete items. For us to find an item to delete or find an item to update, we need to pass a parameter to it. So for the create and delete route, we are basically passing the base route to them. And for the update and remove route, we're passing the param route to them. And just as a recap, if this is confusing to you, remember that our create function takes a route, and that route is basically what we are passing in the index.js file. So we're passing this route into it. So you can use this route to now run base route.posts or whatever. Now let's see what testing this looks like. If I run npm run test at this point, rather I have to remove the skip flag from the test for articles. If I go to articles and rename this to skip to just articles.js, I can then run this test. But before we run this test, let's just go through and see what's going on. All these are just importing utility methods and setting a different port for test so it doesn't clash with our normal dev port, and then an environment for test. Then we basically before the test runs, we seed all the test runs, we seed our database, and after all the test runs, we flush the database. And then we're basically like doing things like testing for post requests, put requests, delete requests. We also have a get request here. And if I run this test one more time, and see start testing the articles endpoint, but we should get an error for this, and I'm going to show you why this failed. And why this test is failing is because we at each of the tests we are saying that every response should be a 200 to tell us that this was successful, but the response is a 404. It's getting a 404 for each of the endpoints. Now the question is, why are we getting a 404? The reason we're getting a 404 is that in as much as we imported articles inside, we assembled everything inside articles/index.js, we haven't actually told the entry point about this route. So remember, index.js exports the register route method. What we can do, and then it takes a router. What we can do is head into the index.js file, import this this register articles route we created, and then right before we mount this router, what we want to do is to register this route. Just call the register route function and pass it the same router object. And if we save this and try to run the test one more time, our tests should start passing because we now have we shouldn't be getting a 4 anymore. You can see that each of the tests are passing. The get passed, the post passed, should post an article, should have an insert ID, which both are fine. You should update an article and should also have a modified count that greater than 0, which is also working fine. Should delete an article and should also have a deleted count that's greater than 0. And once it's done with this, it will drop the database. That is what the flush method does. The seed method seeds the database, then the connection tests also, and the home page, the home test as well. Yes, looks fine. Cool. Now at this point we're done. We're done. I'm just checking if you have questions, and no, we don't. Yeah, so we don't have any more new questions. What we need to do next is actually deploy these changes to Azure. The problem with this is if I push this code right now to GitHub, the code depends. This code depends on environmental variables that are not currently available on GitHub. So this is actually not going to work. And those environmental variables are the ones we set here. We set our connection strings and our database name. Now what we can do is head back to the deploy.yml file. And just right before we run the npm install and the npm test command, because if I push this right now to GitHub Actions, the test will fail because it wouldn't have a string to connect to the database, and then the deploy would fail, which shows us why things like having things like CI/CD is important. So you can just keep pushing things and be rest assured that if you have enough test coverage and things break, like if you have enough test coverage and the deploy is successful, you can have some confidence that everything is working fine. But if you don't have enough test coverage and things, if you don't have if you don't have enough test coverage and things break, you might not be able to cover like most of the gaps that might happen when you're writing the tests. I'm going to set up an env variable here. And what this is going to do is just like what we have with the Azure credentials, we are using the MongoDB connection string from the secrets and setting up this env variable here. Now, once this code starts running, you should be able to get this from the processor.env object. Before we push, this will still fail if we push because we have not set up the secrets in GitHub. So we have to actually go to GitHub, go to the repository we have here, head to settings, go to secrets, then add new secret. And the first secret we want to add is the connection string. So we can just copy this, paste it here, then copy the value as well. Paste it here and just add secret. And we can add another one, which is the database name. And just in case if you're thinking of probably like taking this video back, pausing and like trying to steal my connection string, I definitely going to delete the database after this workshop. So don't even stress yourself. Now, I've just added these two credentials. Now what happens is if I push this, if I commit all these changes, let's just name this, let's just give this worst name ever, and then push to GitHub one more time. Yep. If we head back to actions, you should see that the new commit is being built right now. If you open it and then go to build and deploy, and chill for a while and watch the process complete. So if you have any question while we're watching this build, please feel free to drop them in the Q&A. It seems that we're seeing a lot of greens. We have like login worked, setting up node worked. All our tests seems to be running fine. So if you notice, it's the same test we had here. So right now it's now deploying our changes to Azure. You can see this was successful. And the entire job was completed successfully. Now, if I go back to the terminal and run call one more time, I should get, rather, let me do, let me copy this. So I'm still running call on for what I want to do is run call on the production database. Why does it say multiple line? Let's copy this. Come on. Yeah. Then paste. Yeah, you can see my production database is working. The new endpoints we added should be working too. So if I go to /API, I would get an API response. If I go to /API/ping, I will get a ping response. If I go to /API/ping with data, I should get a post response. And if I go to /API/articles, let's hope we get, yeah, we got an empty array, which is because we haven't seeded our database. And if I try to seed, let's say I try to run npm run seed. Oh yeah, I need to remove this check. Go to seed.js. Basically, change this to settings. Test is equal to if settings exist. Then take the settings dot test, else just set it to false. Now, if I run this one more time to seed, give it a minute or two, you can see the seeding was Hello, Sam, can you hear me? Hello? Hello, Sam, can you hear me?
Yes, yes.
Yeah, I got disconnected for a minute. Sorry, but can you still see my screen? Can you still see my
Yes,
screen?
everything is all right. Just repeat the last point.
Okay, cool. Okay, so what I'm going to just do is just go back to what I just did previously. So what I just did was to edit this seed file. I had a bug in it initially. Just edit this seed file to make sure that it checks if it's in test mode, which we're going to pass through the settings. It will use the test data.js or test data.json. If it's not in test mode, it will use the data.json. So, and what I've done is I ran npm run seed, as you can see here. And this npm run seed successfully added items to our database. So if I run call on API/articles again, because previously I returned an empty array, if I run this one more time, hopefully it should give us some test data. Yeah, you can see we have like all these article JSON data here. Oh, so just like I promised, this is, yeah, I'm just 2 minutes late. I told you I was not going to take up to 2 hours of your time. I'm going to try as much as possible to reduce it to 1 hour 30 minutes. Remember, every single thing you need for this workshop, everything for this workshop is in this repository. If you ever feel stuck, please come back and take a look at it. Okay. I'm going to take a look at the questions and ask a few questions before we go. Hi, James. James is asking how to restrict APIs to countries only. This is totally out of the scope of the workshop. I don't know how to do this, but I know you can do a lot of tricky stuff like basically start with not allowing people to register. Like if you have authentication, start to making sure that people from a different country cannot register, and you can use like geolocation libraries to like protect people from accessing the site or the API if they are not in a particular region. Just like Usam said, we're going to this same link that this live stream would have the complete video for you to watch at the end of the day, but you can also go to YouTube and have access to this video. Yeah, sorry about being disconnected. I kind of my Wi-Fi network dropped. Cool. So Hussam, we don't have any more questions, and we're actually done with the workshop. I know this is not just typical workshop, and it was a little bit fast-paced, but I was trying to balance making sure people don't get bored because they live stream and there's no interaction. So I wanted to make sure it doesn't get too long and people start dropping off. So if you missed anything, feel free to mention me on Twitter and ask questions. Or this repository literally have everything you need. Like I spent a lot of time to make sure that I don't miss anything out. So come back to the repository and follow it along. It has every single thing you need for this workshop from beginning to the end. Okay, Hussam, I think you can end the workshop now.
All right, thank you, Chris, for this wonderful session. And as we said before, the session is recorded, still will be accessible on the same live link. So for everyone watching us now, you can keep the link and access it right after the session. We will also try to have it on our YouTube channel as soon as possible. So also you will be able to follow along. The GitHub repository is shared. You will find it in the announcement section. It's the first link. Make sure you follow us also on meetup.com. You join our meetup page. The name of the page is Reactor Abu Dhabi, Microsoft Reactor Abu Dhabi. And for the Twitter, it's a MSFT Reactor. There will be more interesting sessions on the Reactor page. So make sure you also register your interest and join us for the coming ones. Thank you again, Chris, for your time. And thank you everyone for watching us. See you and stay safe, everyone.
Thank you. Bye.
Bye-bye.